Let's now have a look at rearranging some formulae. And so let's take an expression that we did in the tutorial and say we have Q, which is pi d to the power 4 P1 minus P2 divided by 128 mu L. So this is the Hagen-Poiseuille formula for the rate of fluid flow in terms of the diameter, in terms of the pressures at the beginning and end, in terms of the viscosity and length of the pipe. And here you were asked to make P1, I think, the subject of the formula. Again, there are various ways of doing this. Often the simplest way is just to get rid of the fractions by bringing this over to the other side. So we would be allowed to write that again by having mu L Q equals pi d to the 4th P1 minus P2. Now at this point you can either divide by this part if you're after P1, or you can multiply through. Again, with all these problems, there's not usually a unique way to go about it. If I did that, it would enable me then to take this term and take it over to the other side. So when you take that over to the other side, you get 128 mu LQ plus pi d to the 4th P squared equals pi d to the 4th P1. So now in order to express P1 we just need to remove this multiplier with P1. So when it's on the numerator on one side, we'd put it in the denominator on the other. And we can write P1 starting from this side if we want. So we have 128 mu LQ plus pi d to the 4th P2 all divided by pi d to the 4th. Another expression that we looked at is an expression in linear kinematics where you have the displacement expressed in terms of the initial velocity, time, and the acceleration. Now this is slightly different from this in the sense that if you're looking to find an expression for t, because you have a t here and a t squared there, there's no way that you can separate those and find an expression for t. You can't join them together. You can't, if you factorize the t out of it, you still have a t there. So you quickly come to the conclusion that in order to find t, you have to think of this as a quadratic equation and solve it like that, and solve it using the formula. So in this particular case, there's no kind of rearranging that you can do to find the value of t. Again, I'm going to multiply everywhere by this 2 in order to remove the fraction. So if you multiply everything by 2, this becomes 2s equals 2ut plus a t squared. And if you now rewrite that to make it look like a quadratic equation, you basically have that. where these terms are in fact the coefficients in the quadratic equation. And what you're going to do is apply your formula, and you're going to substitute these terms into this formula: minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, you're going to say that t equals minus b, which is minus 2u, plus or minus the square root of b squared minus 4ac all over 2a. And when you tidy this up, you get t equals minus 2u plus or minus the square root of 4u squared. That minus and that minus make all that become a plus. Plus 2 times 4 is 8as all over 2a. Although that is correct, you notice that you can factorize a 4 out of here, and when you take that 4 outside of the square root, it will become a 2. So if we, for the sake of writing this thing out again, if we just maybe continue over on this side, I can write this as t equals minus 2u. Remember, I'm going to take a 4 outside as a factor, which then outside the square root sign becomes a 2, and then inside, once I've taken a 4 outside, that becomes u squared plus 2as all divided by 2a. And so in effect, you can divide top and bottom by 2, or effectively that 2 cancels with that 2 and cancels with that 2. So we're dividing the top line by 2 and we're dividing the bottom line by 2, but that's the effect of it. So your final answer for t looks like this: minus u plus or minus the square root of u squared plus 2as all over a.